Hello everyone, we're going to be looking at relations and functions. So the first chapter we're going to be looking at is its set notation, and this should cover 5a. So let's look at a couple of these definitions here. So the first one is curly brackets refers to a set of numbers. So we need to be careful that we don't use, say for example, square brackets or round brackets, or we just write the numbers out as they are. We don't want to do that. We want to make sure that when we represent a set, we represent the sets as curly brackets. So let's just define a set at the moment. So let's just say even numbers less than 10, or between 0 and 10, including 10. So the set would be 0, 2, 4, 6, 8, and 10. Whoop, sorry. So when we're talking about sets, we need to make sure that we use curly brackets. Now the next symbol that we've got here is an element of. So when we're talking about an element of, we're talking about the fact that these are called elements. So these parts here are elements of the set. Okay, this is the collection of these is what makes up the set. So you would say, if I was going to call this set A, okay, you would say, for example, 2 is an element of A. Okay, because 2 exists in A. Now, likewise, with this one here, if there's a slash through it, what happens is that means that it's not an element of. So, say the number 1 is not an element of A. Okay. Now, let's just say I was going to make a new set of numbers. So let's just say I'll call this B. Okay. And in set B, I'll only have the numbers 2, 4, 6. Okay. And set C, I'm going to have 1, 2, 3 in there. Okay. So this next symbol here represents the subset of, or means is the subset of. So if you were going to look at the elements in B, okay, so B has 2, 4, and 6, and 2, 4, and 6 also exists in A, so all the elements in there have to exist in A, then we can say B is a subset of A. Okay, because every element in B exists in A. It's not this one. It's not A is a subset of B. Okay, subset means that it's pretty much the smaller part of the larger set. If you look at the next one here, it's got not a subset of, or is not contained in. Okay, so you could actually make this statement here. I know I crossed this out, but you could say A is not a subset of B. Okay, you could also say C is not a subset of A. Okay, because you've got 1, 2, 3 here, and the larger set, the overall set has only even numbers less than or between 0 and 10. Okay, so moving on, let's look at this next one here. It says the intersection with. So this is pretty much a way of saying what is common. Okay, what is common between the two sets? So if I was going to ask you what is common between set, so the intersection between B and C, okay, remember we always need to represent these answers as curly brackets because we're talking about collection of numbers now. So intersection between B and C, so we've got B here, we've got C. What's common between B and C? Only what's common. So we've only got the number 2. So the answer for this one would just be 2, but you'd still represent it as a set. So if I was going to ask you, say in a different common pen, what is the intersection between A and B? Okay, what's common between A and B? Well, B has 2, 4, 6, and also A has 2, 4, 6. So you could say, in this one, the intersection is 2, 4, 6. Now, union means that we're talking about a collection. So we need to think of combining both sets. So if I was going to ask you for A, union C. Okay, A union C means that we're collecting all the elements in A and all the elements in C. So I've actually drawn this a little bit too small. A union C, so we need to write the elements 0, 1, 2, 3, 4, 6, 8, and 10. So I've combined all the elements in A and all the elements in C together. Now keep in mind with this, I didn't double I didn't double up on the element of 2, because you can see in C there's a 2 here and there's a 2 here. I didn't write the fact that there was 2 2's. I just wrote 1. So you don't need to make, you need to make sure that if there's commonality between the two, if there's doubles, you just account for it once. Okay, the next one means excluding. So I want, say for example, set A. If I've got set A, so set A, and I want to exclude set B, excluding set B, the only elements that I would have for this would be 0, 8, and 10. Okay, because I'm excluding all the elements in B. Now the next one refers to the empty set or the null set. So if I was going to say, what's the, so we need to create a new set. So let's just say set D here is odd numbers. So 1, 3, 5, 7, 9. Okay, so 1, 3, 5, 7, 9. And if I asked you for this question here, what is the intersection between A and D, sorry, not A and B, there's actually no intersection between, there's no intersection between A and D, because you can see if all the odd numbers are here and all the even numbers are here, there's no commonality between A and D, which means that we can write that this is the null set, or the empty set, because there's nothing that exists in it. Now you need to be careful with this one, because common answers are to say that it equals 0, or it also equals, just blank. Okay, these are wrong answers, because you need to, even though it's got nothing in it, you need to define it as the null set. All right. Now the next few are a little bit different, because we're talking about ordered pairs. Ordered pairs, think of them as just coordinates. Okay, so we're used to using coordinates as x and y. Now we need to define sets of numbers. So sets of numbers, as you can see, I'm going to take a picture and show you what we're talking about. So when we're talking about sets of numbers, we're talking about the whole number system here. Okay, so we're all talking about real numbers. And when we're talking about real numbers, we can think of decimals, we can think of negative numbers, we can think of fractions, perhaps maybe fractions that are terminating or recurring. Overall, we've got real numbers here. So real numbers, it can be divided up into rational, integer, whole, natural, and also rational numbers. So when we're talking about rational numbers, the formal definition is that it's a number that can be expressed by a over b such that b is not equal to 0 and a is not equal to 0, well, could be equal to 0 as well, but mainly it's a number that can be expressed as a fraction. So if you had a number that was, for example, 0.3739562, so on, and there's a string of numbers that can't necessarily be expressed as a fraction, then it's irrational. But for example, if you had 0.25, okay, 0.25 can be expressed as 25 over 100, which can be 1/4, which means that 0.25 is a rational number. When we're talking about integers, we're talking about whole numbers that are from negative infinity all the way up to infinity. So you can see these numbers here. We're not talking about decimals, we're talking about integers. Integers, whole numbers, but it also includes a negative domain. When we're talking about whole numbers, we're only talking about the positive including 0. And sometimes the definition of natural numbers can include 0. But for this sake, we're going to say that natural numbers are just counting numbers. So, for example, I was going to ask you to count the number of apples. Naturally, you wouldn't use negative numbers. You would say there's 1 apple, 2 apples, 3 apples, so on. Okay, and irrational numbers, we've talked about this already. If you type in square root of 2 onto your calculator, there is no possible way to actually express that as a fraction. And pi as well, which we're familiar with. Okay, so let's do these questions now, and let's see if you can work out the rest. I'll give you, well, actually, if you can pause the video at this point and see if you can work these out, and then I'll work these out with you once you unpause. Now let's work out these questions. So the first one asks us for the intersection between A and B, and you've got A, you've got B, and you've got C here. So the intersection between the two is what's common. Okay, what's common between A and B? Well, I can see an element of A, 1, 1, 2, 2. So my answer for this one is going to be 1, 2. You have to use curly brackets. The next one is asking for the union of A union C, which, remember, if you go back up to the definitions, it is a combination. So we're going to be writing down the elements 1, 2, 3, 4, 8, 16, and 32. Keep in mind, I didn't double up despite the fact that it comes up twice. C, we're going to be looking at the excluding. So everything in A, excluding everything that you see in B. So we're going to write the elements 4, 8, 16, 32. Okay, because you want to exclude 1 and 2. Now, this next one here is 3 and 4. So you've got the numbers 3 and 4. And is there any commonalities between 3 and 4 and B? So if you think about it, you've got 3 and 4. Does that overlap, or is that in common with anything in B? So in this case, we call that the null set, because there is nothing. You don't write 0, you don't write blank, you write the null set. Alright, these last few questions here, whether or not 8 is an element of A. So A, you can see the 8 there, so this one here is true. Next one, you've got B is a subset of A. So does every element in B exist in A? Yes. Okay, C is a subset of A. Okay, so it's saying, does every element in C exist in A? So you've got 1, 2, 3, 4 here, but you've got 1, 2, 4. So you've got nearly all the elements except for the number 3. So this one here would actually make the statement C is not a subset of A. So this one here would be false. So that concludes that lesson.